right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Yes, Mr. Q. All right, good. Well, warm-up 51's on the screen. And once again, I'm recording this session because we're moving on. Today, we're moving on to something funner. Yes, that's my word. Go tell your language arts people. Don't care. Funner. That's my word. Let's go. So, anyways, we're moving on today to transformations, guys. And it's going to be like a fun ride. I like this portion of the course. So make sure you finish up the warm-up. From there, get a Cornell note ready. Also, I am going to collect the signed progress or the screenshot that you took was it on the weekend, Friday? Something like that, yeah? Last night's home plate, hold on to it. I'm going to address that in a little bit. But other than that, let's see how we can do with that warm-up. Once you are done, go grab, I printed out a play sheet that you're going to need for today's session. It looks something like this, so make sure you grab one once you're done with the warm-up. They're on top of the cooler. Thank you, Mr. Q. You're welcome. All right, inequality for number 1. All right, there it is. Brandon, Doherty, go. Or equal to 4. Hands if you got something like that. That is correct. And solution set of x such that, blah, 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 or, how will we write this in interval notation? It would have to be 2 different ones, do you guys think, or? Keep that on a lock. Let's go to number 2. Tell your neighbor what you did for number 2 to get started, please. And then Brandon will pass to someone. Brandon, pass someone. Bam. I would write this over 1 and cross multiply, which means x plus 5 equals to x squared plus 5x. What do I do next, Danny? Subtract x and 5 from both sides. Subtract x and 5 from both sides. That leaves us with 0 equals x squared plus 4x minus 5. So far, so good. Next, tell your neighbor what to do next, and then Danny will pass to someone. All right, Danny, go. Martin. Factor, or negative 5 on top, 4 on the bottom. What 2 factors multiplied give me negative 5, that when you add them give us positive 4? Tell your neighbor the 2 numbers. What 2 numbers multiplied give me negative 5, when you add them give us positive 4? Martin, pass someone. Anthony E. 5 and negative 1, so my factors are x plus 5, x minus 1. Anthony E. clutch from the back. Let's go. And what do we do from there? Rebecca. X plus 5 equal to 0, and x minus 1 equal to 0. Let's solve. Minus 5 minus 5, x equals negative 5. Plus 1 plus 1, x equals 1. Tell your neighbor the 4 names of those, please. 4 names. Rebecca, pass someone. I'll start with the first name, solution. How about another name? Jaylene. Zeros. Another one. Clarissa, x-intercepts. Another name, Noah. roots. And have you got that? All right, let's go to number 3. I need an equation for that one. Show your neighbor your equation, please. Y equals mx plus b, which becomes f of x equals something x something. Give us those numbers, please. Noah, have someone? Martin, go. Negative 3x. 5, positive. So it's f of x equals negative 3x plus 5. Let's double check. Yes, plus 5. And then 1, 2, 3, and 1. 1, 2, 3, and 1. Martin in the house. Let's go. Hands, have you got that? All right, copy the agenda, please. Warm-up number 51, transforming functions. Home play, 2 problems, 4 transformations, and you'll know once we get to there. It's fairly simple. You're going to see, well, to me. However, this is a part from this on forward, since we're dealing out with transformations and graphs, some of y'all might get a little bit thrown off, just a tiny bit. So make sure you have your highlighters, colored pens, and all that handy, so like that you can follow along as best you can. Okay. All right. So once again, tonight your home play is 2 problems, basically 4 transformations, and today we're starting with transforming functions. Let's go. And we're getting closer to our Thanksgiving break. I'm going to try and give you your final study guide before you leave. Present from me to you. You know, what else are you going to do during the break, right? Other than clean the house, wash cars, and make breakfast. How about clean your rooms? Ooh, how about them apples? All right. So, code, write this down, ALXN2, ALXN2, ALXN2. Ah. So once again, so you can get your home play from there, and the home play looks something like this. Ooh, look at that, how pretty. Q merch, like a shirt, right? Let's go. $10. Oh yeah, they would fly. All right, here we go. I can transform a function using different parameters. I can transform a function using different parameters. Do me a favor, everyone. Go like this really quick. Bear with me, because today, like I said, we're going to get started. Bear. Anyway. So, we're starting with transformations. We know what functions are by now. So, turn to your neighbor, in your own words, tell them what a function is. What is a function in your own words? A function. Function in your own words. Function in your own words. And I think it was Martin, the last one. Pass someone, Martin. Danny, function. For 1 input, exactly 1 output. Yes. So once again, today we're going to be transforming functions, and we're going to use different parameters. So what is that, Mr. Q? Well, let me elaborate. So parameters. We know what functions are. We got the notes on that. Let me talk about parameter. What is a parameter? Look up to the screen. You don't have to copy this. A parameter is a number that transforms a function into a new function. So when I give you whatever the function may be, I'm going to use a particular number to make that function into a different function. Okay? So, for example, before we move on though, we started with y equals 3x minus 1, which was 2 variable equations. Is that correct? But then I said we're no longer going to use y. We're going into what? Function notation known as f of x. What changed? Tell your neighbor, what's the only thing that changed? What's the only thing that changed, everyone? The y. We just changed the y to f of x. Now, did we do anything magical? Did we multiply? Did we do it? No, we just substituted instead of y. We're using what? F of x. Okay? So that's what we're going to be focusing on today. So, on your paper, I gave you a play sheet that looks like this on one side. Starts with example Q. It says graph f of x 3x minus 1. Yes? And then it has 3 tables underneath. So for the first one, let me go back. That one's going to be in black. The next one's going to be in green. And the last one's going to be in red. So if you have those colors, if not, use 2 different colors for the last 2. But I'm going to start with this one. So let's fill this one in. Now, we've already known how to fill this table because we've done it like so much in our warm-up. So here we go. Look up to the screen. So what do? You take -2. I substitute that in here. So let's do that in our noodle. What is -2 times 3? -6 minus 1, -7. Fill that in. Next value, -1. What is -1 times 3? -3 minus 1, -4. Next value, 0. 0 times 3, 0, and that leaves us with -1. Next value, 1 times 3 is 3 minus 1, 2. And the last value, 2, we substitute in here. 2 times 3 is 6 minus 1 is 5. All right. So let's start with that one. Use your pencil or a black pen. Let's plot these points. -2, -7. -1, -4. 0, -1. 1, 2. 2, 5. And we're going to sketch our line going through those points. And we're going to label, this is the first one that we started with, we're going to label this one f of x. F of x. All right, so look up to the screen really quick. So if you notice on the domain, I'm using -2, -1, 0, 1, and 2. From this point forward, your attention really quick, from this point forward, anytime I ask you to graph something, if I don't give you a domain, your bread and butter is from what to what? -2 all the way to what? 2. That's the bread and butter. So when I ask you to graph something, it's from what to what for x, please? -2 to 2, right? Okay? Anything that I ask you to graph unless I give you different numbers for x. Okay? But other than that, -2 all the way to 2. We got it? All right. So now that we have this, writing utensils down, look up to the screen. Vianney, can you get the light, please, just to make sure everybody gets the whole HDMI digital whatever. Here we go. So what I'm going to do next, I'm going to use a parameter of 5. Look up, a parameter of 5. Are we there so far? Okay. Now, how do I use that, Mr. Q? Well, let me show you. Look up. I'm going to first go to when x was -2. The original f of x, here it is. When x is -2, what was f of x? -7, yes? So over here, since I'm going to use a parameter of 5, I need to use f of x that was over here. So what was f of x? -7. So therefore, what is -7 plus 5? -2. Write that in there, please, in green. -2. Let's do the next one. I'm going to write again the parameter of plus 5, which means I need to go back to when x was -1. Here's x -1. What is f of x? Guys, what is f of x? Negative 4. So instead of f of x, I'm going to substitute here negative 4. So what is negative 4 plus 5? Positive 1. So far we have negative 2. We have positive 1. Let's do another parameter, plus 5. So let's go back to the original. When x is 0, what was f of x? Negative 1, so we write it here, negative 1. So negative 1 plus 5, that is 4. Fill in the rest of the table, please. All right. Show your neighbor what you wrote for the last two cells right there. Make sure you have the same thing as you. All right. What did you write in this cell right here? Jacob. You wrote 7? Yeah, but tell me what you write. 2 plus the parameter of 5, and that gave us 7. Hands if you got 7. That is correct. And how about the last one? Jaden, what'd you write? Which was? 5 plus the parameter of 5, and that gave us 10. Hands if you got that. All right, let's plot those points in green. Let's do that in green. We got negative 2, negative 2. So where's negative 2, negative 2? Negative 2, negative 2 is right there. Next one is negative 1, 1. Negative 1, 1. Next one is 0, 4. 0, 4. Next one is 1, 7. 1, 7. And the last one is 2, 10. 2, 10. Let's graph our line in green for that one. All right. Now, for this one, since the original was f of x, and we just use a parameter to transform our original, we can no longer call it f of x. This new one, we're going to call it g of x. G of x. So, let me take you to your personal space at home and with your family. Let's see if you guys have a meanie person in your life. Let's see. I remember having a little meanie person that if I was eating Flaming Hot Cheetos, they're like, I want Flaming Hot Cheetos. If I was gaming, I want to play. Wow. So imagine this person walks into your home plate tonight and they see this. And you tell them, well, the original is the black one. And the black one has 5 points. If you're going to explain it to that little person, what happened to the black one without using the tables now to be the green? What would happen to the black to be the green? Talk it over to your neighbor. What do you think you should tell them? What happened to the black one to get the green one? All right. Good conversations. All right, Jaden, you went last? No? Who went? Was it Jacob?
Oh, it was.
It was you. Pass someone. Let's go. Brandon Felix, what would you tell the little person happened to this one to now get the new one? Okay. Help him out, Selena. Oh, Selena said count 5 points up or 5 steps up for each of the points. Let's see. 1, 2, 3, 4, 5. It moves that way. 1, 2, 3, 4, 5. It moves that way. 1, 2, 3, 4, 5. Oh. Hands if you agree with that conclusion. That is correct. So, let's think. Here's my original. This parameter of plus 5 gave us this green one. Tell your neighbor what's going to happen if we do a parameter of negative 2 to the original. So, without using the table, I want you to show me f of x minus 2 and see what happened to the original in red now. In red. Now that you talked it over with your neighbor on your graph. Graph me the new one applying the parameter of negative 2. All right. Yes. So Jaden said, so we get the original one, Mr. Q, and we just do a negative 2 to all the points? That is correct. So where would I place this one, Jaden? This point, which is negative 2, negative 7, where do I place that one? Negative 9. Bam! That is correct. Which means this one would be at negative 6. This one would be at negative 3. This one would be at 0. This one would be at 3. Let's sketch that line in red. Let's see, did it go 2 steps? 2 steps in what direction, guys? Down. Down. Yes. So 2 steps. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Yes. All right. So let's write our coordinates for this one. We got negative 2, negative 9, negative 1, negative 6, 0, negative 3, 1, 0, and 2, 3. All right. And so on and so forth. From 1 to 5, how comfortable are you with this so far? All right. What if I said this? I want you to show me with blue f of x plus 8. F of x plus 8. Use blue. Tell your neighbor what you're going to do to the original one to show now in blue on that graph. All right, show your neighbor. Oh, and by the way, once again, since we cannot label it f of x, this red one, we still label it g of x. Anything after the original one is g of x, okay? Now, eventually I'm going to switch letters to maybe h of x, I of x, j of x, but for right now, let's just keep anything after the original, g of x. So, give me points for this one, f of x plus 8. Points. Ryland, go. -2. What is it? Hands if you got 1. Looks about right. Continue. -1. 4. Hands if you got 4. Looks about right. About 0. 7. 1. 10. And 2. 13, somewhere up here. All right, so then we do that one in blue. I think I put the wrong point on the last one just because it doesn't fit, so something like that. Hands if you got something like that. Let me put the point over here, and we're going to label this one what? G of x. Yes? So once again, are we clear as to what happens with a given parameter once we apply it to f of x? Yes? Okay, explain it to your neighbor, please. What happens if it's a positive? What happens if it's a negative, please? All right. All right. Laura, what happens when it's a positive? What happens to f of x? It goes up. How about when it's a negative, Miroslava? It goes down. So therefore, underneath that example, I gave you guys this one. And it reads, graph f of x, there it is, it's shown. Graph in green, g of x equals to f of x plus 4. So do that right now in green. You don't need a table. And then in red, I want you to graph me f of x minus 4. So g of x, the first one in green is going to be f of x plus 4. And in red, f of x minus 4. I'll give you guys some time. Go. Recording. Now, David, go. Points for the green one. -1 and 2. 1 and 6. 3 and 2. 5 and 6. And if we show that, and we label that g of x, we label this first one f of x. Hands if you got that for the green one. Yes? Okay. So far so good. Not bad, not bad. How about for the red one? Give me points for the red one. Pass someone, David. Martin, points. Be nice. Yeah, the -4. We're doing the -4 right now. -1. I got it. He's got it, he's got it. -1. Yes, let's go. 1. -2. 3. -6. And 5. And this is our new transform function, and we label that g of x. From 1 to 5, how comfortable are you with this so far? Okay, guys, what we just used is one parameter to transform the original function, either going upward or downward. Okay? That parameter has a name. Look up to the screen, write your utensils down, and it looks like this. The parameter is called k. And you pause the tunes in the back. Once again, the parameter is called what? K. So anytime somebody's talking about the parameter of k, you're going to tell them that it's going to move the function in which direction. Tell them. Explain to them. It's going to move the function in which direction? All right, so our new function, g of x, is given by moving the original function using the parameter of k. In which direction does it move it? Martin, go. Up and down, like this. When does it move up? Positive, yes. And when does it move down? When it's a negative. So whenever we have a number here that's a positive, it moves the entire function up. Negative moves down. Okay, we got it, yes? All right, turn your paper over, please. And now we are here, example super cute. We have this first table. It's going to be our original, f of x in black. This is going to be in green, and this is going to be in red. So fill in first this one in green. I think it's blank here. Put x and f of x minus 5. And for the red one, f of x plus 4. All right. So, with that said, let's fill in our original function. Yes? Here we go. So our original function, it says f of x equals x squared. So, students, quadratics, yes sir? Yeah. Quadratic students. Here it goes. So if I substitute, look up to the screen, my first value for x is what? Negative 2 there. So what is negative 2 squared? That is correct. Fill that in. Next value, negative 1 squared. Positive 1. Next value, 0. What is 0 squared? 0. What is 1 squared? 2 squared. All right, let's plot our original function, negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. All right, and here's our graph from left to right. Let's sketch it, look up. And we've already did a soft introduction of this about a month ago. Remember this one? We called it a parabola. Parabola, yes? And we're going to label this what? Tell your neighbor. F of x. That is correct. All right. How we doing? Good? All right. So, now here's where this one's going to differ a little bit, okay? And also, from this point forward, whenever I ask you to graph a quadratic function like this one, what values are going to use? The original, negative 2, negative 1, 0, 1, and 2. You got to get used to these points, guys. They're going to come up all year. You're going to be going to get your Arnold Palmy, and all of a sudden, quadratic functions. Let's go. All right, look up to the screen. Writing utensils down. Look up to the screen, please. This is where I get some people a little bit challenged with this idea. Look up. I'm going to go back to the previous one really quick. Let me show you the table. I want you to notice, let me zoom in, that we have f of x, nothing inside with x of f of x. Do you guys see that? And we just either add or subtract to f of x. However, look at this one that we just arrived at. What do you guys notice inside with f of x? Now, a number inside the parentheses. Once again, let me go back to the previous one. Was this number inside of the parentheses? No, it's outside of the parentheses. Okay. And we arrive to this one, which is inside of the, oh, my bad. inside the parentheses. All right, so here it goes. Writing utensils down, look up to the screen. I'm going to do the first one. Stay focused, please. Here it goes. So I'm going to go to green, but I'm going to use this function. Here it goes. And they give us a parameter of -5. Okay? Look up. Up. So far, so good, yes? All right. However, yes? Hold on before you write anything down. So, what is 3 minus 5? Everyone? -2. What is -2 squared? Write that in there, please. You're like, whoa, I know. Let me guide you through the next one. F of. Tell your neighbor what number we're going to write here for the next one. What number do we write here? 4. That is correct, because that's what x is. So what is 4 minus 5? What is -1 squared? 1. All right? So now that I showed you that pattern, start filling in the last 3 cells, please. See what you get. All right. Danny, what you get for the next one? 0. Hands if you got 0. How about the next one? Anthony, D. 1. Hands if you got 1. And the last one, everyone? Okay. Yeah, we got it, yes? All right. So, let me zoom out, and let's plot those points. So we got 3, 4, 3, 4, 4, 1, 4, 1, 5, 0, 5, 0, 6, 1, 6, 1, 7, 4, 7, 4. Let's sketch our parabola from left to right. And this one's going to be labeled what? G of x. Hold on, let me fix it because I think I went a little short right there. Oh my goodness. All right. Something like that, yes? Hands, have you got something like that? All right. So, you're just doing your graphing, and in walks your little person in your life, and they ask you, how come this one is over here? What would you tell them from the original one now that we are in the green one? Tell your neighbor, please. How would you explain that? How would you explain from the original now being there? All right, tell your neighbor, please. What would you explain for that? And we'll have Brandon enlighten us. All right. What would you say, Brandon Doherty? It moves what? It moves the function by what? And move the left and right. And move this one to the right. Be more specific, to the right. Everyone. 5 steps, that is correct. 5 steps to the right. All right. And look at the parameter. Look up. What was the parameter? -5. Inside with f of x. Okay. So with that said, tell your neighbor what's going to happen with this one, that is f of x plus 4 instead of -5. What do you think that's going to happen? Once you discuss it, go ahead and sketch your red one, the red one, for the parameter of f of x plus 4. All right, how we doing? All right, show your neighbor, see where you're at. Hopefully they have something similar to you. All right, look at the coordinates, make sure it's in red, labeled, and then we're going to have Benelli enlighten us. Once again, show your neighbor what you did with that original. What you do with the original. Let me have some of my Circle K coffee. Quick plug here on YouTube. Hopefully I start getting some free coffee or something. Right? They should hook me up, right? Am I right? Am I right? All right. So, give us coordinates. Danelli. What do we do to the entire original f of x? We move it what? 4 to the left. Hands, have you got 4 to the... Oh, let me change that to red. 4 to the left. Hands, have you got that? That is correct. So I go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Look at that. How beautiful. Q merge, let's go, right? All right. So, but isn't that kind of odd though? Look up to the screen. That when it's a positive, we go to the left, and when it's a negative number, we go to the right. You're like, yes, Mr. Q, unless there was already a negative in there by itself. Am I right? Am I right? All right, so from 1 to 5, how comfortable are you with that so far? Okay, so we still have a little bit of time. Look up. With this one, show me in green f of x minus 2. Do that in green. And in red, f of x plus 6. So, Jaden, what do I do in green? So, for the sake of time, I'm going in which direction? You said to the right. Hands, if you agree with that? That is correct. So I go to the right 2 steps. 1, 2. 1, 2. 1, 2. 1, 2. This is my g of x. Therefore, for this one, Brandon Felix, which direction? Let's go. 6 steps to the left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. G of x. So, before we leave, write this down, please. That rule, g of x equals f of x minus h, close parentheses, plus k. This is going to be our transformation rule. Hold on before you leave. K moves it in which direction, Martin, you said? Up and down, and the h moves it in which direction, everyone? Left and right. All right, have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.